So let's begin learning. As I said, we are going to break this session into two parts. First, I'm going to teach, and then we are going to test. So the first part is more of the machine learning concepts. The expectation is people don't know anything, and it's perfectly fine. It's perfectly fine. Challenging task to really take anybody and just be able to go through that. So but we are going to do that. As I said, it's going to be very basic. And my approach of teaching, I think the overall approach we follow is like try to be very simplistic. So everybody can understand that. Taking stories, simple examples, and build through it. So it's not like scary, like math and science, these algorithms and all of that. With some sessions which I see, they immediately start with a big statistical formula that's a type, and then slowly half of the room just walks out. And that happens. So we're not going to do that. Some people may still walk out. That's a different story. First, let me ask you a question. What is machine learning? What comes to your mind? I'll take some answers from you. Guesses. What is machine? Yes, very good. Yeah. What else? Okay. Right, absolutely. Definition, which I think was touched in point, is the way of machines, method of machines, and to predict data using some historical data and come up for future predictions. This is more official or more standard definitions. I don't like these kind of wordy definitions and things like that. What I like to do is like take some example or take some story, usually, and explain that. So I'm going to do that. So most of you or some of you, or at least know what traditional programming is, what really happens. So I'm going to contrast that with machine learning. What happens in the machine learning world and the programming. What is it? You have data. You have, let's say in this example, we have data, simple example. Data is 1, 2, 3, 4. That's it. Okay? And there is so some programmer is going to write a program. Let's say this simple program they've written, and they're just doing a square of x. Right? They write a program in any favorite language of theirs, Python, Java, whatever they want to write it, and they're just happy about it. Oh, let me test it now and see what happens. They test it, and the output comes out as 1, 4, 16, right? So you just got the results of whatever data you put in. You say some particular number, 3, and you get output is 9. And the program is successful, and it just continues to do that stuff when some input is given and output is provided. Mostly contrast paradigm shift in this approach. And what's happening over there, you do start with the data. You have x is equal to 1, 2, 3, 4 for this example. You have the output also, right? You also have an output in this case. The solution is actually given to you. And you have 1, 8, 27, 64. So what is it? What's going on? Is it cube? Yeah, as you mentioned, or somebody thinks differently. It's just a cube. Human mind is very quick to answer in 4. If instead of 4 numbers, I give you 4 million. You know, this is not happening. Even the smartest of the folks cannot do it. And that's where the power of machine comes into picture. The machines can take the time, and they don't get tired, they don't bored, they don't ask for salary hikes, and they don't want to sleep, anything. They just keep on doing that iteration. In fact, in time-wise, they might take more time. If you do the same problem to machine as quickly as at cube root, machine might take actually slower than you. It might iterate in this thing. Machine has much more speed. What I'm trying to say is like human mind is just not tactical enough or practically to make answers in that thing. And then you get an answer which is cube root by using humongous amount of data or even small amount of data. And then you can use that program. Now this is the program. This is the model which you have got. The output is actually a model, a program. And now the number comes in 5, and you get the answer is 125. So it's shift from what traditional programming were there. The programmers wrote a model, a program in the traditional world, And here it's shifted around, and you have the question, you have the answer, and the model is being fine-tuned or found out what is going to be the model by machine learning programming. And it's going to fine-tune and try to get you the actual equation, formula, or all of that. There are pieces which programmers still have to do. We haven't reached to a point where everything is going to be automated, and then that scary world of like where it's all the jobs. It's still scary, but it's not that bizarre scary, which I think at this point of time is sometimes some people get afraid of. But it's scary. Give me a quick formulas on this. So we move to some of the examples. One of the very classic example for machine learning is spam, because everybody pretty much has email, right? And the unfortunate truth is, if you get an email, and everybody has a spam folder also, and many times you get more spams than your emails. And even if you not got an email, if you just create an email and 2 hours later you might see spam already happening. You didn't tell that machine that this is a spam or Gmail or Outlook or whatever, but it's happening. How is it happening? That's machine learning. So the Google servers and the Outlook servers over a period have realized and created filters, and self-learning has happened. They have identified much robust way to find proper email versus spam. But okay, friends, what you do, this is junk, this is spam. So you are helping the machine to learn a little more. You are helping that behavior pattern in machine learning world, which we'll talk in a few seconds. So there are 2 different examples. The machine was self-learning, and then you are teaching or helping hand. So we'll talk about that. I will bring those terms and definitions in a little bit. But this is a good, simple example. Most of the classic books use this example starting point. But there are tons of things happening in machine learning, tons and tons. You name it. Self-driving cars to fraud detection to something facial recognition. Very, very interesting. I think nowadays every day I see in LinkedIn somebody has created an application, and there's a program written, and somebody peeps in and says, initially the person peeps in, his name is popped out, and this is the person. Recently I saw there was one which was tracking facial expression and just saying your reactions, like bored or excited and everything, as people are changing the expression. So we are very soon going to be having many more applications around the facial detection. I think you can start realizing who is paying attention in the class, who is not. It is just like amazing use cases or interesting, crazy things in certain ways also can happen out of that. But the world is moving towards that. So those are a few examples. There are some other examples which have been highlighted: facial recognition, object detection. This is a very helping hand. How many of you have Alexa or home or something already at home? Both of them, okay. Else, what are you guys doing? You should take it, right? I mean, at home, you'll soon realize I have Alexa thing, and the kids use them much more than us. They have some interesting ways of using it. My elder one, every night he just talks to Alexa and says, how's the weather tomorrow? And accordingly, he'll say that I want to wear a jeans or a short and all of that. So he just figured. And my younger one has stopped asking questions to me. He's in 4th grade. He said, Dad doesn't know much. He doesn't say that. I can sense that he stopped asking me and keeps on asking Alexa, what is the coolest planet? What is the farthest distance of the distance? Where is moon? I don't know all of these things. Why do you expect me to know? And Alexa is patiently answering. So I'm seeing the world how the pattern would be. I think they will be just talking to each other, and they're talking stories. There are some stories which they say, do you want to go to the garden or you want to go inside? You'll say garden, and the story will change its path. I mean, the narration of the story will think. So it's amazing, exciting world. The dark side to it, which is the fear that a lot of jobs may go. And it's not a joke. It's serious. It will go. I mean, there's no point lying around and saying, no, it's not going to happen. And it's always happened. People give an example like, oh, horses were there, and people came with the cars, and it changed, and people adapted, right? It was all good. Yes, but the change is too fast to adapt this time. I think it's harder, I think. There's a whole part of the society which I don't think so really catch up. I hope the mechanism of the society catches with it. But I think what the example is, what is the most in California? Anybody? Most of the people doing is truck drivers. One of the things which is easily doable and with all these routes very straight and doable. It's doable. So think about it. What happens? The number one job gone. It's not only that. What it impacts is all those the rest of things around the freeway which are built around this economy. The self-driving car is not going to take a stop to have a burger on the street, right? It's gone. Think about it. So it has impacts, and it has serious impacts. It's not as scary as the Skynet of the world, and that's far away. And people are worried about that. There's nothing to be worried about that at this point of time. Other worries, which I'm talking about. So just wanted to throw that side of the implications. But should we stop doing these things? Mostly not. Even if we try to stop it, it's just going to happen. There are various use cases and example technology is going to take over and build on it. So there is nothing denial out of it. To bring this particular slide, how many of you have heard about Gartner company? Gartner somebody? Yeah, okay, folks. So, which every year, I mean, what do you have heard about Gartner? Magic Quadrant? What's very common is like Magic Quadrant. They have a quadrant and they'll say in the CRM space, Salesforce is the leader for this year, and so and so company is second or not second. They don't do ranking like 4 quadrants: leader, niche player, all of that. They figure it out, and that's what people hear. They also do many things, as pointed out in the audience. One of these things, they create this curve called the hype cycle, and this curve is drawn every year. The curve remains same. The curve doesn't change. It remains same, but its plots pointers change the positions, and they go depending on what is happening. It's a very fascinating and interesting example, or this slide, which is very useful if somebody is looking for the career direction for themselves, strategically thinking where the world is moving on. Because if you think about it, I'll take a few moments to explain this. This is the initial part. This is the innovation trigger, and this is the point where somebody in garage, 1 or 2 guys are trying to figure out something which is very crazy. The rest of the world has no idea what is happening. There's something called 4D printing. We haven't printing yet, right? We don't have 3D printers at home yet, but somebody's figuring out 4D, actually 5D, and more so printers. There is something called smart dust. You name it, all kind of crazy things in the part you will not see. Progress ahead, we hear more of the things which become more common vocabulary. How many of you have heard of IoT? Most blockchain thinks these things have become smart robots. We know Roomba and so many other things which are already in place. So these things are happening, and our dear friend machine learning is yellow, blue, light blue circle in the middle. It's right in the pinnacle of the hype, and that's why I was saying, right? I think it's the crazy buzz around machine learning, and there's a clear evidence or research so extracting the data compared to all of these things is happening. What happens after this point is which there. It's always in life, everything. This curve is very interesting. This graph is very interesting. This is not only for technology. It happens to us over and over again. The things which we buy, we get very excited. We say, iPhone 10, I'm going to order it. I'm anticipating it. I ordered it. I'm waiting for it to come. And it comes and I say, forget it. It's useless. It's nothing different. It's very much same. I even lost my home button now. It's so bad, right? So that's a human psychology which happens, and this curve just keeps on happening. Things, relationships, anything. You have a trip, you think there it's not that great. But then you realize like, it's not that bad as well. And life kicks in and you say, okay, there are several good things about it. And then we reach something called a plateau of productivity, right? And a plateau of productivity means these things are household things. This curve had some big data some few years back. I'm sure this curve had microwaves in this curve some point of time. Like, for now, like microwave, what is the big deal about it? Some point of time, it was a big deal, right? There is a technology which can create popcorn at home. Wow, what kind of piece is there? So eventually things move out. So you don't see car and things like that over there. They move out of this. But as the excitement and buzz is around this initial phase of it, it keeps on growing and it has its different phases. Also, color coding, which is light blue, is 2 to 5 years, which will become the mainstream and be commonly used. And I think machine learning is already happening and forming in certain shape and form. Many question this when I bring this slide up or something. Oh, machine learning was happening in 1980s and 90s, and it's just gone, suddenly disappeared. Anybody has that feeling reaction?
Well, yes. Early 2000s, I remember artificial intelligence. That is quite different than what artificial intelligence.
Very not only in the 2000 early, but 1990s and 1980s, there was a lot of talk around it. It didn't go anywhere. The algorithms were there. The logic, the algorithms still existed. What happened all of a sudden? I think the challenge there was the bandwidth, the capability to take facial recognition at that point of time, take all the data points and say you are angry, and you change in a second the face and becomes like, okay, now it's frustrating, or he's bored, and so all of kind of the emotions, or somebody's excited, any of those emotions very quickly to find it. I think that with the bandwidth and the capability did not exist at that point of time. I mean, think about an application we have put in here right now, and we can see who is really interested. I can make out some facial expressions, but it's like the machine really trying to instantaneously say as things are changing. So that was the difference, but I think it's here to stay. In fact, right, support the bandwidth and capabilities, the storage, the big data of the world, all of that was not there. It's already actually a household. The fact that we have the Alexas in the world and it's working, it responds. It's most of the time it's work, accent or not, it just responds pretty well. It's pretty sophisticated. It's amazing to see that happen, and that's in place. This deck, I don't have the 2017 one. The 2017 one is very similar. Machine learning has not gone out much. It's just year by year only. It's moved maybe a spot here and given a space to deep learning. So that's coming here. So machine learning still continues to be hype. It's not a bad thing. It is a natural thing. I've been in the big data space myself 6-7 years now. I think my observation of perception is thinking is what happened is as the volumes of data increased, people got the technology of big data. They knew how to now ingest big data or bring in big data, store it in right format, structure it. They did some analysis themselves with the traditional tools, but it was limited. If I give that 1, 2, 3, 4, instead of that, I had millions of numbers and asked some report to run over there and somebody to eyeball it. It's not going to happen, right? It's not workable solution, and that's why machines are thought as the silver bullet to really solve that problem. So that's the next pioneer effort that people are thinking, that humongous amount of data, turning interesting applications. It's at the juncture of all of that, the technological revolution, the availability of algorithms and stats and everything, and the amount of data which we can store and have. All that has come out to the right time, and people expecting that machine learning to be that. And so, interesting slide. I think I usually like to bring it up, and I think it helps in a lot of different things as well. Not only just machine learning talks about what is happening really in the industry, and you can look in that every year. I'll share that with you folks. So, who are learning offerings? So, machine learning algorithms have been there for a while. The later part of 2015, I was noticing, I think all these companies, like, we're just churning out like their offering. Like, okay, Amazon came in with this, we have a machine learning offering. Weeks later, Google came out and gave an open source TensorFlow, which is their machine learning internal use for years, and now they just made it open source. Like a war happening to chase who's going to be the earliest and fastest in this space.
They have opened their training also, right?
They have opened the training. It's been a lot of changes in open source and open culture now. Azure, Microsoft came in late in this game, but still they're doing pretty well. I think Satya Nadella has transformed the company into a cloud, and a lot of action happening. They still have a chance in this whole battle. I'm going to try to do a demo with machine learning on Azure because it's very drag and drop and very easy in such a group, and initially in an hour or so. That's the fastest to translate the information. I'm going to try to do that in the later half. Your work coming from the big data world, there is something called Spark, which has a machine learning library within that. And Spark is the processing engine of big data, very fast and sophisticated in memory. We spend a lot of time in our programs doing that. So that's another offering. There are other flavors. Obviously, there are many other ones. There is Mahout in Apache, IBM there. There is generally people use R. Statisticians use R to do that. Python is being used. It has a good set of libraries as well, the pandas, numpys, and scikits, and all of that. So there are various offerings. I just wanted to bring in some of the big players, what they are doing. Everybody understands this is game changer, and we need to be here. And that's why they are there and they're putting all the investment and energy behind it. Any questions so far? So let's get started with the first concept. What I try to do is like go to step by step, very basic concept. We are building blocks and then teach others bringing everything together. So we'll take those baby steps. The first thing which you need to understand, there are two kinds of learning in the machine learning world. There's something called as supervised learning, and there is something called as unsupervised learning. What are they? So let's take an example. Let's say I have an example. I have a basket of fruits, right? And these are like plastic basket fruits. Let's say it's kindergarten kids are playing or something like that, plastic fruits and everything. And what our problem is, we want to segregate these fruits. We want to put all the bananas one place, all the grapes, all the cherries, all of them apples in one bucket, or just segregate them. That's our problem. All the smartest people on the planet to really do this, and they are the kindergarten kids, right? They're the smartest, right? If their brain activity is so high, if it is continued that way, I mean, human being can be like better than machine, honestly. If that scale, it stops after some point. We get down, simply. So this is fun as well. So any activity you say, they'll come running and jumping and they will partake in the activity. And within a short period of time, they'll do this. They will segregate all these apples, all these bananas, all this stuff of that. Nobody gave them a manual. Like, okay, this color has to be matched and go around and think. They say, this still it is an apple. This one is big, still it is an apple. They know it. How do they know it? They have either learned through videos, books, learning is just put in their head, or by the parents, all of that which has happened, and that ability or that data which they have is called as trained data, and if it exists, you have the trained data, that is called supervised learning. The answers are fit in their head. They know this is the apple, this is the banana. Even if it is small size, it's blackish, it doesn't matter. So that training data is there. Let's take the same example again. This time I'm not going to call the kids, but I'm going to call aliens to do the same example. This time I'm making some assumptions. The aliens do not have fruits. Lucky us, right? We have fruits. Let's say they don't have fruits, and I'm making the assumption they are not colorblind. Those are two assumptions which I'm making. With that assumption, I say go ahead and do this exercise. What they end up doing is something like this, because they don't know what is this banana versus this. This is green and this is red, right? It's really different what the answer they have resulted, because they did not have this super trained data. Nobody gave them trained answers, or that information was not there, and that is called as unsupervised learning. It's still useful. Whatever they have done is still useful. It's not useless. It's a different kind of grouping, right? It's not doing my thing, but it's doing something which could be used in certain ways. So that's the basic principle which I wanted to ingrain in your mind about supervised learning and unsupervised. Is it making sense? Yes? Same thing is written all these things in big words, but instead of that, I think the pictorial one makes more sense, right? So we do that. Don't worry about the details and what is written. It's just the same thing which I just explained to you. There's some names. Ignore that as well. The aliens could go further down, and it can say not only red and green, they can say red and big size, red and small size. They could do that. Still not what we expected, but some more refinements. All that is unsupervised learning still. So that's kind of the first bucket. Then, one level down now. Supervised, unsupervised world, there are three different machine learning techniques, and they're called as classification, clustering, and regression. If you know, letters are made red purposefully. I used to teach kids, right? So I play all these memory techniques. So the acronym CCR, you need to remember CCR, which stands for clustering, classification. When I start talking, you talk. It's clustering and regression. Because if you have this acronym, you will remember this for a longer period of time. The whole idea is that, right? So it's not just you came here for 20 minutes to learn that and forget it immediately. You want to remember that. So that's CCR, classification, clustering, regression. Pay attention. So that's what we are going to do. I'm going to explain each of them, what they are. And again, this is very important. I will give you the answers. Actually, I'm going to put those hints within that. And when we are doing the problem, you will need those hints. So let's go with the CCR. The first one is classification. Class a technique where it is more like a tree. and it's like a decision tree, which we call as. You ask a question, and it probably has two answers, yes and no, like the way I had previously. It says, this car, the mileage prediction, it's heavy, yes or no. It says yes, it's high mileage. If it is no, we ask another question, and it says yes, no. End of the day, in a real problem, it will not be two questions. It will be 20 or 200 questions, maybe a huge, gigantic tree. But through this decision mechanism, what we got is buckets. These buckets of data into either high mileage or low mileage. It doesn't have to be two: mileage, medium mileage, low mileage, very low mileage. It doesn't matter. But aggregating by asking this question, this or object, people, it groups. Question?
Yeah. So here you've taken it as like on the basis of the starting node is weight. Somebody else can start the decision tree and old person.
Right. This is a human being. It will do that. The machine will not do that. Machine, if two machine programs are doing, it's the job of the machine to find that which is first and which is not. You are not giving that formula to the machine. The machine is going to churn the data and say, oh, the weight seems to be the most important thing. It will do all the permutation combination and come out with weight as the most important thing.
But is it? I mean, it just analyzes data and fixes.
Correct. It you have provided, and permutation combination is trying to find which one is the most important attribute. And there are ways that you fine tuning as a programmer you can do, and then you can say this, I want a little more, and then your spectrum will go further and say, but just by this question, it's more than enough to do this. 90% of my data gets sorted out by this high mileage and low mileage just by knowing this. And this is the finder. And actually, you see the tree progresses, the percentage is low. The most of the things are done in this conversation itself. It's designed by the algorithm. I want to keep it initially, we'll take it later. Yeah. But the whole point is classification is a decision tree. You keep on asking questions, and you get buckets. Is that making sense? Classification is doing that. Now clustering, CCR, right? So clustering is the next one. Clustering is a technique, and when is the only technique out of the three is unsupervised. Right? So we supervise, supervised, and clustering is the only which is unsupervised. The rest are obviously the other one. So it is unsupervised. Whenever there is unsupervised, I call them the aliens. I call this aliens, poor aliens on the planet, and we ask the question: the whole thing in the on our planet Earth, and they observe this thing, that there are things which are brown, and they run away. They run towards you. If it's a line, it comes to eat you, or it runs away. But it runs away in certain directions. And that is called as animals. Animals which are green, and they don't run away. You cut them, you shake them, it does nothing happen. Right? They don't run away. So this was an observation they did. They didn't have a formula or the trained knowledge to say this is planet and this is plant and this is animal. What they did is they just observed a few things, and based on that, they came up with this observation, and that is called as clustering. Right? Yeah. It gives some conditional attributes, and based on that observation and everything. They didn't have a formula. They didn't say, oh, this is a mango tree, and this is and this is a mango tree. No. Or these are the plant trees kind of a thing. They just observed and see the patterns and define some buckets within that. So that's the clustering. Second example. So we're going to keep it a very high level this way, but when we sum it up, it will all come together. The last is regression. You have kids, or you young kids especially, you have seen this graph. What is this? This chart, first 2 years of your kid's life, the doctor keeps showing you over and over and over and again this thing. So every week initially, then every month you go there and they measure your kid's height, weight, head circumference, so all kind of parameters. And what they do is they chart it on a graph, and they say, let's say this is the weight, and age 1 and 2 and so much is there. So based on that, they draw some lines and say there's 60% chance, 50% chance that your kid is going to be around 70 kg or 155 pounds or whatever at the age of 70, right? So they are doing this mathematics using this line is they're trying to plot historical data and project what is future. Whenever there is a line, it's called regression. That's where regression is. Also, in difference, previous two techniques were giving like groups, if you would say, mileage, plants, animals. Regression tells you exactly the kid is going to be 67 pounds. There is a number. There is a specific number. Is that making sense? Is the only technique. I'm giving you answers and hints, which I'm going to look for later. It's giving the exact number. It's saying this much weight, this much height. If they're saying, it's not saying heavy or light. It's not saying that. It's not saying average, overweight, obese. It's not saying that. It's saying exact number. So this is the only technique which does that. Right? Making sense? So those for classification, clustering, and regression. Now the next where it gets complicated. Am I saying that there's no math involved? Nothing is needed? No, I'm not. The problem which I have is like most of the times the sessions are like starting with this. Okay, let's start doing random forest. And they say, oh, I heard black forest. That was a good cake, but I don't know what this random forest is, right? And it just starts in a different way, I think. I think my approach is like, let people get familiar, get some ground into that, and then go to the algorithms and things, instead of just giving a complex algorithm formula in front and start with it. So that's where we lose people. Actually, I'm not even going to go into the algorithms. I mean, in interest of hour or so, it's not practical to go through all these algorithms. I'm going to give you a method or a cheat sheet which is actually going to make it life easy. Without knowing these many things, you can still progress, and we will try to solve without that solve this problem or some of the problems, right? But I'm just want that there are algorithms underneath each of them. There is regression ones, there is classification, we have the clustering under the unsupervised, and so on and so forth. But we are not going to go in each of them in detail yet. So that was just things. Let's recap what we did. So we talked about in general about how the machine learning has evolved, what's happening, why is it so much hype, who are the players in it, and then we talked about an unsupervised, CCR, which stands for. Some people are paying attention, or at least not sleepy as yet. So that's kind of the format for that. And now what we're going to do, and now I'm going to portray a problem, a project, which we all together will try to solve using just the knowledge which you have got, and some more hints which I'll go and give as we progress, right? So that's what you think. It's more a test phase. Let's see what you have learned. So to be able to solve that, this is the problem. So this is actually a real problem which we had with one of our clients, and many clients have this problem or need, because everybody has customers, and they want to find if you have a happy customer or unhappy customer, right? Why do you want to know? What's the use of that? Retention. What else? Relationship. Exactly. If you don't have money, why do I care? Actually, that's a very good point. Actually, I have another example which we'll bring later point of time. It actually matters a lot. And a lot. Right? So it makes a lot of sense. It's a very useful tool. If you know, you can have your messaging. If you go to a customer happy and say, hey, by the way, we have this other product. He's saying, forget it. I'm returning your first product. Forget the second product, which I'm not buying from you. Right? So that's kind of the relationship. And suppose you go and ask to that same thing to another customer who is like very happy, excited about your service, product, and sell them this product. And yeah, they'll say, why not? Yeah, that was a great service. That was a great product which we had in the first experience and everything. So the messaging has to be right. The customer is unhappy. You may better want to talk about why is he unhappy? Does he need some better service, or what is missing? Is there gaps in the product? What is that? Start in the conversation. If you're not aware, you're naively just going and saying some messages which is actually doing opposite for you. So many things can happen. So we had this problem. Actually, we had a hackathon actually, which me myself or a team was part into that. And this is a banking client, and they were scoring us customers. Nowadays, everybody's scoring customers. You have all kinds of scores, 50 scores, satisfaction scores, and several kinds of scores which people have. Not just the credit scores, but there are tons and tons of different kind of scores which people have. So we have this client which wanted banking customer which wanted that kind of thing. So this is actual whiteboard picture which we have taken, and we thought through it, brainstormed it, and say, okay, to be able to do this, we need to be able to find whether the customer is happy, so unhappy. So this is just a real-time problem which we're just trying to talk. And seeing this, we first need to score the customer. We have some mathematical objective way of doing it. And this is a very basic one. Actually, this was a hackathon, which 2 days you have, do whatever you want, 48 days, and solve this problem. So which we initially started with. So we came up with this, and we thought we'll do some scoring. How do we do that? And that's where the domain expertise come into picture. And I was saying that as a data scientist, you need to have the domain expertise. Or, which if you don't have, you talk to the subject matter experts, right? That's not going to work always if you're a data scientist, you're expected actually. But in this case, we were not. So we went to the data subject matter expert, the banking experts who are relationships and kind of people, and asked what are the attributes which help in defining this kind of attributes. And they gave a list of 43 attributes. I said, no, we have just 48 hours. 43 attributes and trying to decipher all that is too much. So what we're going to do is we're just going to take 5. Just going to keep it simple. This is a hackathon. We don't have to perfect it right now. We will. And actually, we ended up being like that. So we did that. And we defined a few attributes. The first attribute we said, for example, I'm not going to go every one, but just an example, like check-in. We call it as last check-in. If a person is interacting with that bank very often, that he's associated, he's engaged, right? He's using it. If he's just not using it, it's like, there's some problem. There's some other bank he's engaged with. There's a situation we need to understand with, right? So that's the fact. So what we did is like simple formula to start with. It's a rule-based engine initially. Like, okay, if you're engaging within 1 week, you get 20 points. 8 to 4 weeks, which is a month, 15 points, and so on and so forth. If you have not engaged in 6 months plus 5 points or something like that. We just started with hypothesis, which we call in the word, and we put it. And afterwards, once the machine learning is pictured, machine learning will say, no, actually, if he's engaging 12 days, that is 20 points. That's what the algorithm will take care of. It will try to find those factors and multiplication factors. It will do it. But you give it some initial ones. Here we go. And we did this thing and several other parameters around it, and we started finding some scores around the people. Of course, we started giving some, the customer asked actually, so we participated in this contest. This was 2 rounds. So first we got selected, the first 5 were selected out of 120 so ideas across, this was a large corporation in different cities, and submitted. We got 3rd place, barely made it somehow into that. But we continued working on it. We talked to the customers. Actually, I had access to talking to the customers, and I spoke to Arizona Bank, which was the biggest client, and all of that, and then came out with this thing. They said, we want indicators, like just this number. We want indicators that say traffic light, green, red. Red means the customer is going to leave. But actually, if you think about it, this is all useless. If you know 50% of my customers are going to leave, and it's red, it's useless. It only creates panic, right? Because you don't know what to do. I just know they're going. What do I do? The important thing is this, the action. What to do now? And because this data and math, you need to have to provide that and say the service is the problem, the distance to the ATM is a problem, this is a problem, and that is a problem. What are the common themes which is resulting in this case? Or case by case, this customer is probably going to leave because of this reason. Because we have seen the pattern in the history, right? All these customers in this vicinity were leaving because they had to drive so many miles to get to a bank or ATM, and nothing was there. So all those kind of situations come into picture. So this is very useful. That's the action, the recommended action. So with this exercise, in the second round, we continued working, building a lot of things, and then it became a whole initiative, a data initiative in this project. Obviously, they do a hackathon for a reason. They picked it and took it on the product, and building on top of that, getting the data from various sources. This is the bank, as I said, this brick and mortars, ATMs, all of that, and there is digital sources. Customer call-in, these days, smartphones, smartwatches, all of that, beacons. I was surprised, like banking industry, what kind of innovations, what kind of crazy things they had. Mechanism, when you come in, if you have an app, they can identify who walked in. Oh, the CEO or an executive of so-and-so company has walked in and so much balance is there. The people know. Versus somebody, he doesn't have much money, just don't care about him, right? So the analytics does exist. It's not so prevalent yet, but it does exist. That's beacon technology, which also is in place. Retail is also using that. So that's the different sources. First of all, trying to get that data into a centralized data lake, which we call as in the big data world. All the data is transformed, ingested, build a pipeline, and have that into the thing. In the world also, there is something called as omni-channel, starting from one channel and doing. Now banking has all these things, I think. You can withdraw money from your smartphone, literally say, I'm going to withdraw on this branch and have $200, and walk in there, without your ATM, and there is a one-time PIN, and you can generate. So that's starting from a digital channel, and then you're finishing that up as a actual brick and mortar ATM, right? So that's a very big thing for these companies. Apply some machine learning, algorithm predictive on top of it, and then do several things. And these are customer tasks, like give us an engagement meter, give us a customer information dashboard. Actually, when you go to a bank, many times the teller person asks you to swipe the debit card, right? As soon as you're in a screen. Because as soon as you do that, a bunch of information pours in. It literally tells him like, okay, you have so much money, you have such a customer, you have been, the score of yours is so much. You don't know. Now he knows a lot about you. And then he quickly says some of the recommendations and suggestions that you can do this and everything. Actually, the data is very powerful. Many times they say you, oh, you have so much money sitting in your saving account. Do you want to farm an FD? Right? This is which they ask if you have money sitting in your bank. Instead of that, if they were very practical, which we were suggesting there, if they say, oh, based on this money, if you just do one transaction and let me click this button and do this FD for you or this transaction, you'll start saving $200 per month. Now it just opens up the light. Like, $200 is not bad. It's just going to start saving me 200. Versus saying like, you are going to save money in general, right? So that's power exercise we put it together. Once that can be used in any channel, whether it is they're coming on the branch, whether they're calling the customer service, or whether they are doing mobile app or website editing. And that you can channelize, not the same communication to all the customers. Depending on what I know, it's a happy customer versus unhappy customer. I can say, oh, can you refer your friends and relatives? I know this customer is happy, so he will or she will refer. Or versus somebody is very, like, no way, forget about referring, I'm leaving myself, right? So it's a very different conversation. So that's the power of data which comes into picture. So under the hood, this got engaged, we involved data scientists and everything. I'm not going to go in those details on this project. What I'm going to do is actually now ask you guys to solve the problem. Now, what's the problem? What trying to solve? What is the problem statement which I framed so far? What the client is having, or the need which the client is having? Okay, but how are we approaching it? What are we trying to find? Guys are thinking it's very simple. What are we trying to find? What is the customer? Yeah, that's it. That's what we are trying to find. Keep it's very simple. All these are ingredients. It will help in retention. What are the algorithm, the characteristics, on a thing. But let's think about this as a problem, right? I want everybody in the same page. The problem is finding happy customers, unhappy customers. Okay? Who are solving? How are you going to solve it? So let's recap what we did in the previous thing. We talked about CCR. We talked about supervised, unsupervised. What I didn't teach you or talked about is algorithms at all, right? That do this, and I'm going to give you another tool which is called as a cheat sheet. Literally, it is called a cheat sheet. I'm going to give that away. And there are many cheat sheets. One such happens to be in Microsoft. It doesn't matter if it is whichever cheat sheet, you can use it. What this cheat sheet does, I mean, I saw this Microsoft cheat sheet, and it was very interesting. I used to do this CCR thing, and I looked at it. Wow, it's very interesting. It has a CCR. There is this whole side, this right side of this is all classification, whether it is two-class classification or it is multi-class classification. Right? It is classification. Swing out here, and there is a regression. So it just, the CCR maps very well into this. There is something more called anomaly detection. There's one piece which are not CCR, but other things that covered. Now, with the guard for the CCR, and with this, we're just going to go ahead and use the cheat sheet and try to solve the problem. Remember the problem, first of all. The problem is unhappy customers. We start point, right? And we just keep on going one step at a time. And see the question. The first stop is, are we predicting some data points? Are we predicting something about something, somebody? Yes, we are predicting. We are predicting. And so predicting, we're not clustering. Clustering is just observing and saying, yes, you are plant and you are animal. Just observing. It's not observing. We are predicting something, right? So that's what is this group which we are going forward. So we move forward. We are predicting categories or values. Categories. So as we move forward, we keep moving forward. I moved this group, so categories. How many categories? 2, right? Unhappy. So which led me to go down here now. I go back here and come to this section. So with just the basic knowledge what we got in the last 5 minutes, an hour or so, you navigated this cheat sheet and you came up to this part and perfectly came out to that part. And that's what we have to use. You have to use a two-class classification. That's what defines the algorithms. Like there are a bunch of algorithms under it. Two-class SVM, base point machine, bunch of them. Many more are there. So these are there. I haven't taught you these, right? How to navigate to this. And the good news is it actually doesn't matter, right? Even if you blindly use any of them, you're going to be right. As right as a weatherman, right? It's going to rain tomorrow. They don't guarantee it will rain. I mean, it doesn't rain, he doesn't lose his job. He doesn't lose because he said, oh, there was 20% chance. I didn't say it is going to rain. I said there is a 20% chance. So we have reached to that point. You're going to be right to a certain extent. You're going to be right. You're going to be a lot right, actually, but just by coming up to this point, whatever we did. But you're not going to be perfect. Now, the job of the data scientist, of this effort to take that advanced level, is coming from the 20% to how to become 95%, 98%, how to get that closeness, right? Tuning and dialing, which we keep doing and doing and doing till we get something better. Is it perfect, 100%? No, it's not going to be. Data science and this predictions are just not guaranteed. It's probability game most of the time. So that's what it is. What happens in defining this is these two things. There is a speed and accuracy. These are inversely proportional. If you have a problem, I give you 10 seconds, and I give you a multiplication of a 5-digit number to a 5-digit number. How many of you will get it in 10 seconds? Very easy. Let you calculate it. Just to punch in those things, 5 seconds is not enough, right? If I gave you the same problem, 5-digit to 5-digit multiplication, I told you take an hour. Use your calculator. Easy, just do it in an hour. That's fine. Even if however you want to do it, most of you are going to be right. So what happened? Accuracy is changing because of speed, and sometimes speed is very important. And you let go accuracy, right? The weatherman is not necessarily the perfect example. If life-threatening situations, your diagnosis or the results should be very, very important. If Google says, oh, out of 7 pages of my website, they have only 5, it's okay. Google is going to move on with the speed. They're not going to wait for my website to be caught up with every single page of the chain. They're going to move forward. Their crawling engine is going to move forward. So there are situations where data criticality is so important. So you choose between those and fine tune, right? So far, I just wanted to keep it at a very high level and bring it to the situation where we get to this point and use the cheat sheet and our basic knowledge of CCR. Is it making sense? Yeah?
Is this cheat sheet something out of the box, or is it again something that is customized?
It's always there. It's standard one. You don't have to use Azure for it. Any data problem, you can just take it and start solving using that. That's perfectly fine. Yes. We'll do that. Some portions of it, but not all that. We'll do a demo in a little bit. Yes. Yeah. Now a little bit, right? Change the problem. We said it was going to be. How do you get happy? How do you know? How do we know in that whiteboard? We did a scoring. When I score a customer, it says 67 score. That means maybe say 80% score out of 100, 80% score is going to stay, right? So there was scoring. Let's say our problem is changed. Now we're not going for happy and happy. We are saying we are trying to find that number for each customer. We are fine tuning and letting the machine learning to find things. Now you navigate and tell me if I want to find the exact number, like each customer, how much the score is going to be, which section should I use of the CCR? Is it sinking in? Right? Because I told you like regression is the only technique which gives you a precise numbers, right? The rest of them are categories. High, low, type of that, right? So that's regression. Good. So that's the point which I wanted to bring out and things. So powerful. And actually machine learning is getting very commoditized in certain ways with all this hype and buzz. It is getting easier and easier. If there is a PhD guy who spent 10, 20 years of their life learning all of this thing, they get it. Like if somebody, I can have the courage to really say in 2 hours, I'm going to teach you and involve you to solve a problem. It's commoditization is, right? And it's to some extent the packaging of done it, it's practically possible. You did it, right? You guys went through it and PhD that. I'm not undermining the value of like doing the PhD in knowledge and everything, but it's still practically possible even to even dare this thing. I don't think it's possible a few years back, or it's just not practical to do that. And algorithm systems are doing that and drag and drop and make it easy for life, and we'll use one of these examples of that. Okay. With that, before I jump into the demo, I'm going to cite a few examples. And this is one site which is actually created to showcase machine learning capabilities. And what this site is like, it's a fun site. It predicts people's age by the images, right? And I've been told, don't use on ladies. It's impolite to ask guess their ages. So I'm going to behave, and let's play this game. So let's guess this gentleman's age. Let's see who comes closer. Okay. 42. Okay. Okay. Let's go for it, and let's do that. So the machine predicted, the algorithm predicted 36, right? Now I think I've been told not to go to ladies, but we'll go for this image. It's a family. So picture is going to find three people. Picture will find three people and say which one is who is what age. Let's guess. Kid is a year old. Okay. Year. Oh, okay. You have been trumped. Okay. Okay. What about the others? At least the gentleman. That tactic. Okay, let's check it. It is actually an interesting game. A lot of people have started using it as an interesting game, and actually you can upload your own. You can upload your own photo or somebody's photo. I was doing this session and somebody said, I literally took my kid's photo and just checked it. It was right. Kids mostly gets it right. Is it perfect? Is it going right answers? Right? It's still not. The things are, it is using facial detection and points and things like that. I will tell you, if you use glasses, you're looking it is going to look, at least for the algorithm perspective, and maybe for the what is called a short-term attractiveness, it is, yes, actually it is looks older. It does. Again, the beard and all of that, it does matter. So it's just looking data point. It's not perfect. You can just play yourself. You can put an image without the glasses, with the glasses, and to say, oh, I've become younger in few minutes or seconds, right? So it's just another site. Actually, it is created by Microsoft to showcase this. There's another one. If you didn't like this one, you might like this one. If you have an image of a dog and you want to find which breed it is and you don't know, you can do that. And you can use these images. And which one is this? The dog lovers. It's Scottish River. So basically, you can go through these images. You can upload your own dog images or this particular dog which you find. You can do that. So that's for fun. But you think about, reflect back what is happening. What is the input and what is the output coming in? Input is images, right? Forget about the fancy web page and all that. End of the day, it's a bunch of images which are supplied, and the algorithm is running on it and trying to use some characteristic features and all that, and trying to predict either the age or this characteristics or grouping in that. Each one, what kind of model which is trying to do? Regression, right? Why? Number which were coming in, so that's regression. This could be some other ones, right? It could be, which one is this one?
Multiple.
Give a thought a little bit. Is it predicting about the dog anything? No. It's just an observation. It's just clustering it. It's just clustering it. It's just an observation. It's saying, oh, this picture, this category of this dog, right? That's what it's doing. This is the basic knowledge you can start applying and thinking what really is happening in this world. So it's not that cryptic. It's not that crazy, at least. At least you can apply some common sense and really go forward with it. With that said, let me move forward, a step forward, and try to do the demo, how this could be done potentially. And we have the Azure up on the page, which they call as Azure Studio, Machine Learning Studio. Before I go there, I'm just going to point a few things. So what Microsoft is really trying to do, which everybody's trying to do, is capture this market space. And in this space, Microsoft has really reduced the pricing and ease of use of it and all of things intentionally to the big cloud daddy, which is Amazon. So for this thing, it's literally, think about it, this is free for up to 100 modules per experiment. And for so an hour, so much data. Paid version is $10 per month. Nothing. You pay for Netflix almost this much. So those kind of things can be done. So it's a lot which can be done within a short period of time. So it's all idea behind to really grab the market share. They don't even need the Azure subscription or something. You can just literally just associate and start using it and sign in. So this is one of the tools. It doesn't happen to Azure. This can be used with Azure or independently also it can be used. You don't need Azure subscription for that. But Azure has all the SQL Server data, all of that, everything inside it. Yeah, like Amazon as well. Yes, everything. What we are going to do is we are going to do a quick demo about how it is used. After it is done, it's created something like this. So that's the model which gets created and everything, and everything is a drag and drop. So to be able to do that, I'm going to use experiment, which is the terminology which Microsoft uses. It is not general terminology. It is Microsoft specific, but pretty simple. Let's get started. So there is what we're going to do is we start with a blank place experiment. You start with a blank one. It creates a canvas for you, and you can name whatever you want to name it. In this case, we are doing income prediction. We are going to predict the income of people, and I think in the beginning we were talking about it's very important to understand the income. How many of you get at home private jets flyers or brochures of private jet? Ask you, right? Either me, right? Why do we don't get? Why do we keep getting Home Depot and Subways and Chipotle?
Yeah, not very.
Right? How? But somebody has figured, right? Somebody has predicted or understood this demographic and this locality, everything is happening. So that actual number is very important. So what this algorithm is trying to do is trying to predict an individual and say his income is above 50K or lower than 50K. The same number could be changed. Somebody say 5 million, 5 million, right? 5 million income, send the private jet thing. I think chances are high that we may even look at it. I mean, actually the other way around, he will buy or do something about it. So it's a tool of doing things. Somebody is doing the market research and analysis. That's what is happening. The next step is getting data. So getting the data, we are just going to use the sample data which is available for 30,000 individuals. You can bring in your own data, plug in, and all of that is possible. So it's going to happen in a box over here. So you have this adult census data. You drag and drop that. And for now, you can visualize that data if you want it. It's 32,000 records. It actually has it. It is now this 32,000. If you notice here, it is saying greater than 50,000 or less than 50,000. It will predict the answer. So it is which kind of learning? Supervised or unsupervised? Supervised. They're available. The trained information is already there. It's saying for these 32,000, we know the answer, right? These 32,000, we know the answer. Now, I didn't teach you one thing, which is called as splitting the data. What you do in your machine learning problems, you break your data into two parts. Certain portions, let's say 70-30, 60-40, whatever, you do it. You break first part, the bigger chunk mostly, and train your model on it, right? You train your model on it. And then 30-40%, and you do a kind of a test data. You say, oh, my model says this particular person is going to be over 50K or not. And then you actually check, okay, is my model saying right or wrong? If your model keeps saying wrong, your model has some problem. Your model is a weatherman model, which we don't want. Then we'll have to go back to the drawing board. We have to do some other things and fine-tune it, and get better, and you are satisfied with that, and you will productionize it. So that's why it's very important to do two things: training data and test data. Is that making sense? You need two sets of data to prove that. You need to check, right, whether your model is right or not. That's a testing data which you have to define. So in order to do 70-30, and how to do that? Again, here also everything is drag and drop. So there is something called split data. We take the split data box, we attach it, we give 0.7 means 70%, and there's some samples which we don't want. We just eliminated that, like some seed data or something like that. Now it's the most important step. Which data science and machine learning experts are focused about algorithm. It's just a piece of it. It's just a small piece of it. But it is an important piece. And how do we get to that? In the first part, that's what we did. The whole point of doing the cheat sheet, going through the whole thing, was to find a algorithm, right? Which we find. So either it is coming through a data scientist, knowledge, experimentations, all of that. This decision has to be made that you're going to choose which algorithm. In this case, it's two-class boosted decision tree algorithm. I'm not going to get into how we picked that. In certain extent, we went through it, right? It is, again, it's above 50K or lower 50K. So it is a classification, right? And it has two values. So it is two-class classification. So that's why one of them has been picked. So we have picked it. Now, what we're going to do is we are going to go and find them. He's going to search that name, find that box, just drag and drop that data into this and connect it. Now I have a model based on this. Finding the model. Again, another box for connecting with that. And we need to, in getting it, we are trying to find a new field called income. Actually, it should be called as projected income or something, right? We're projecting and saying this is the income. Run that and use it. We are going to do something called as score the model. We're going to score this model. We're going to test that. So there is the evaluate model option, which is going to use the test side of the data. We're going to connect it. If you notice what is happening is all these boxes run a single line of code, right? And it's all drag and drop right now. So that's the beautiful part of what Azure has done. It's pretty neat and easy. I think it's a good starter for anybody who wants to get its hands dirty. And then these models can be exported out to your Spark world or other world. You can do that. So to run this, it's pretty straightforward. You come in, this whole model is built, and then you run this, and it's going to spin around for a little while depending on the data size. This is not that huge of a data size. It's going to get queued here. If you notice, it's just churning through it, and soon it will be completed and finished running. And then you can look into few attributes and results. So you got a new field called income, and then you also got probability, right? Remember, it's all about probability. Scored label, which is this much, and the probability. So both these parts are equally important. Go back and see in the machine learning world, there are four things. Something negative, true negative. You said it's going to be income is going to be higher than 50K, but it actually turned out to be opposite. Or you said it's going to be positive, it is positive. So you're trying to find that kind of scenario. Your goal is to really get this true positive and true negative as high as possible, and that's your correctness or validity of the model. And there is fine tuning and defining which you keep on doing. And there are terms and algorithms, which are terms and definitions which help you define that. So in short, what we did, and now this step was trying to show you can create a web page or web service on top of it. So the images, and then you create a web page on it. Now you put your image and you get an answer. You put your image, and I think then it becomes an application or a good product which can be happening. So what you noticed in a very, very brief, short example, which we quickly tried to find, and now we found so many people who have income more than 50K. Oh, we can go ahead and send them the Costco or the Home Depot flyer, right? So kind of the logic and marketing, that's a very valid use case, right? Marketing people don't have a budget to send to every single. I think the flyer itself will be quite expensive. It will has to be a nice beautiful one, right? It cannot be just on a rough 4 by page home printed paper. It is going to be much better. So it's an investment, and nobody has unlimited budget, right? You have to target your marketing efforts or any efforts accordingly. So that's what we're doing. And taking this example, I just wanted to showcase you that in terms of content. Anything else? I think that's pretty much from the content perspective. Any questions?
This is going to be very so that it can happen. I mean, of course, Power BI is there. Can it integrate virtualization products?
I mean, so it can integrate with different products. Think about this as just a piece of data which has been churned out. Now you take that data and put it into a SQL database, do anything with it. It's up to you, and create another project, an initiative which will create some dashboard in Tableau, or it's up to your use case. Are you creating an alert system, a list? It's all use case by use cases which can be built on. If you're going to continue to use Microsoft and keep it in there, I mean, all these things can be saved and models can be kept in thing. Data can be flowing into some of the places where you have the data, actual data rather than the sample data. You can do all of that, or you can export it. That option also is there. It's all compatible. It's all PMMI compatible models which can be exported out and used in other places as well.
I have one more question. So I come from where we have another term called item. So I've seen, especially when a lot of they said that there should be a training, and then what's the
I'm not in this world. There is training just to. There is not
and that
third.
should be able to predict your model from that problem.
Just not going to. It's going to be a finding for you, and then you take measures and definitions. Oh, not this algorithm. I need to churn out these attributes. I need more data. I need less data sometimes. Actually can help you. Sometimes there is cluttering of data, more features which you're providing actually can hurt your algorithm. So all that matters. So that's where the next piece of things coming and refining and fine-tuning. Session is like keep it as simple as possible. And the concept, we talked about supervised, unsupervised, we talked about CCR. Remember that when you're driving home, keep talking about CCR. Doing that. We took a real life example. This is not made up. It's a real project which we did for quite some time from the banking project, and multi-year initiative happened out of that, and you walked through and saw the cheat sheet for that. You saw some of the quick demo of Azure. It's a very lightweight thing which we wanted to show and get you triggered and excited about doing that. With that, hopefully this was a helpful session. Thank you very much for joining tonight, and I'll hang in for a few more minutes. So thank you. Thank you. Thank you for all passing to everybody.